When I first started having discussions about becoming the substation manager here, my first question was, well, I'm a civil engineer. I don't know that much about electrical engineering, and there's no better way to learn stuff you don't know other than someone asking you a question you don't know the answer to. You gotta go find the answer. Goes back to the first thing, like have knowledgeable, experienced people around you can ask for help and learn things from, but then like put yourself in situations where you gotta figure it out.
Greetings and welcome to another edition of the Sounds of Solar podcast. I'm host Christoph Brun. Joining me today, my esteemed co-host, as always, I'll let you introduce yourself this time.
Russell Hamilton.
Wow, guys, looking great. I see you got the polo memo today. You see our guest has a nice polo on too. In a moment, before we introduce him, what's been happening? We were recently at an event. I don't want to timestamp things too much, but we were live. We were at Gateway to Solar. That was great. What's happened since then? Russ? Anything besides your escapade to Florida?
Florida was fun.
Florida was fun.
Yeah, Florida was a great time. Thanks, Rob Cack.
Shout out to Rob. I know he listens to the show.
Florida's good. Just visiting a client down there. Had a really good 2-day visit. Good meeting. Other than that, just enjoying the fall.
Yeah, I'm
ready for
peak fall colors in Minnesota.
Ready for the snow to fly and the snowmobile out and do some ice.
You have a snowmobile?
Andy does.
Andy does, yeah.
So I guess since Andy does, like,
Andy is block-headed, like.
It'll be like, it'll be both ours. It just stays at his house.
It's the same thing. It's like the e-foil's like, yeah, I have an e-foil. Well, it's technically Andy's, but like I use it.
No.
Prahlad, what about you?
Just mellow weekends, to be really honest.
You love that.
No, you went up to Bean and Bear Lake.
Yeah, I mean,
tell us about that.
Yeah, we did a 7-mile hike, which was pretty cool.
Mm-hmm.
In that lake, it was lovely to see the colors. And first, we wanted to do it, I think 2 years back, but I think we started the journey and then we realized, this is not a quick one. So.
No, it's not. That's the thing. When you do that hike, that's the thing you're doing. And then you're basically getting dinner after and that's it. Like,
so to give a little perspective, when I did my hiking camping trip, my hike through, that's the first place we stayed was Bear Lake. Right?
Yeah.
So we packed everything.
Those pictures.
It was like a whole day to get there, So
yeah, it was a beautiful colors. Like, I started appreciating the reds.
Did you have sun?
Yep.
Okay, it can always be a little temperamental.
Yeah, I got run down when I went out there, but at night it was nice.
And it's it was peak season as well, so you had a lot of people coming in, but it was beautiful. It was like, I loved it.
How about you, Chris? What do you got going on? Any shows lately? Anything?
Yeah, my band is playing a show coming up and we have a keyboard player, so check out, well, actually X Rodeo doesn't have any released music. We're recording a record this winter though now. So February we're going to be in the studio, which is going to be great. So yeah, we're going to play at White Squirrel in St. Paul, which is my favorite venue in St. Paul.
So you are, and it remind me, the lead singer and the guitar.
I am a co-lead singer and the only guitarist.
The only guitarist.
Yes. Yeah.
I like it.
Which goes both ways, yes. I do play some hot solos,
Okay.
Yeah, they're pretty hot. Anyway, moving swiftly on, we have a very special guest today. It is the substation manager here at EVS, Mr. Colin Paarmann. Roll that applause. Now, the fun fact, Colin and I started on the same day at EVS. Do you remember that day, Colin?
I do, yeah. I fondly remember you were employee 98. I was employee 99. We made it into the top 100.
Who was number 100? 100. Was it Jake?
I think it was
because Jake was here for...
We all started on the same day, so...
Yeah. Someone was maybe 100.
Someone was 100.
Yeah. Double digits. We're well past that now.
Mm-hmm.
What were you, number?
130, I think.
You started after us?
Yeah.
I was like 79 or 81 or something.
OG.
No.
Yeah. Get that tattoo on you somewhere. 75.
I do.
77.
Yeah.
Colin, tell us about yourself. How did you arrive as a substation manager at EVS? What's your history?
I went to North Dakota State University, same alma mater as Russ and a few other folks at EVS, and I am a civil structural engineer by training, and so right out of school I started at a big engineering consulting company, and I've really done substation engineering my whole career.
Mm-hmm.
And so had an opportunity to come over here in 2021, was kind of one of the first few members of the EVS substation department. As the team grew, you know, the rest is history, as they say, and I kind of fell into this substation department manager role. So,
is that what you studied, or what was your? Did you have any substation courses that kind of helped you out?
Yeah, I mean, substations is kind of a unique niche in structural engineering. It's not like a thing that you take a course on in college necessarily. So I was a generic structural engineer when I graduated, right? And honestly, when I started my first job, I don't even think I knew what a substation was for the first. But you know, you pick it up, and like at the end of the day, structural engineering is structural engineering. It's just whatever application you use it in, and so that's kind of specifically what I focused on. And then over the years, you start to pick up some of the other aspects, get a little bit insight into the electrical engineering and some of the other stuff that goes along with it. So
awesome. And
yeah.
Substation itself, like, did you start with solar or renewables, or was it just substation standalone and then you started solar started coming in?
I actually started on what we would refer to as like utility substation work. So think about whoever you pay your power bill to, right? Like that utility has hundreds of substations likely, and so they're constantly doing upgrades, expanding those substations, building new ones. And so it was specifically for that kind of stuff. And then over the years, where the company I used to work for started getting into solar as well. And so that was my introduction there. And then here at EVS, that's like most of what we do is renewable what we call collector substations.
What is a substation?
Yeah, let's define.
Folks out there that don't know what a substation is, what is a substation, Colin?
So the root purpose of a substation is sort of fundamentally to change voltage, right? So there's a beautiful transformer on the wall behind you there. That's kind of the
Like Optimus Prime, or what are we talking about?
something like that. A little bit different.
All right.
The purpose of what we would call a power transformer, a main power transformer, is to change voltage of that specific location in the grid. So we pump power through the transformer. It has what you'd call a low side and a high side. So lower voltage on one side, higher voltage on the other side. And the purpose of that is that there are different pieces of this vast power grid in the United States that are at different voltage levels. And so in order to connect those and transmit energy long distances, you need to be able to change that voltage so that those things can all interconnect nicely.
So, okay.
What is the input voltage and what is the output voltage? Or are these variable?
Totally depends. In the context of renewable projects,
yep.
You know, you're generating power at a very low voltage, right? And if you want to transmit that power long distance, you want to step it up to a high voltage because it's much more efficient. You have less losses. Mm-hmm. And so typically the voltage that power comes out of the solar plant is 34.5 kV kilovolts. Mm-hmm. And then once we put it through that transformer, we'll step it up to what we would call a transmission voltage, which could hypothetically be anywhere from 69 kV all the way up to 500 kV. There's some parts of the United States that are even higher than that.
Diving back into my original question, What is the difference between a switching yard, a substation, a utility substation? Is a distribution substation, collector substation?
So collector substation, or what you might call a generation step-up substation, you're collecting the power that's being generated and stepping it up to a higher voltage to put it into the grid. Distribution substation would be the opposite of that, right? Like you probably have a distribution substation somewhere near where you live that's receiving power from the grid and stepping it down to a voltage, what we'd call a distribution voltage, that then is distributed to people's homes and businesses and wherever it's needed. Other types of substations, you know, if you have like a transmission substation, you may have, say you have like a 230 kV transmission line and a 138 kV transmission line that intersect. You need that transformer to step the 230 down to 138 or vice versa so that those things can link up. And then the last subset of stations, I guess you would call a switch yard or a switching station. And the difference there is that there's no transformer. The whole purpose, actually, Rob Horoff at EVS put it nicely that it's a fancy junction box for transmission lines. It's just different transmission lines, all of the same voltage coming together and linking up. And so like if you're building a new renewable project, you usually need some form of this in order to connect with the transmission grid. If there's an existing line and you want to tie a new renewable project into that line, you build a switch yard there, bring the line in one end, and then that same line goes out the other end, and then you have another line position where you tie in your new renewable project. So
switch yards are almost like a requirement, basically. You can't really do without them when you do solar.
Yeah,
Those pretty much.
often. Yeah, I mean, usually with a typical renewable project, you have kind of three components. You have the plant itself, whether it's solar or wind or battery or some combination, right? You have the collector substation. So it starts at the plant, goes through the collector substation, and then into the switch yard, which is like the final point that the POI, the point of interconnection, where it connects to the grid, is usually how that works.
So for what we do for collector substations here, which says majority of the work that we do, break that down as far as like, what do we do? Like, what are we designing to what degree?
We do what we would call full engineering or IFC level engineering. You start with a design that's maybe at 30%. 30% can mean different things, but it's kind of a conceptual, preliminary level design. This is kind of generally the size of the substation. This is generally what equipment we want to be in it. And then we take that all the way through the detailed design to the level where the contractor can go out and build it.
Right. I guess my question was just like, what part, the structural part, the civil part.
Oh,
We've got like multifaceted.
Like what is it that we, yes, right.
Yeah.
What are we doing? SCADA, right?
Right. Yeah. So, similar to a solar project, substation is broken out into different, what we'd call design disciplines. At EVS, those all kind of fall under one roof under our substation department. And so similar to a solar project, you have civil, like site design, grading, stormwater, that kind of stuff. You have structural engineering. That's my background is, steel structures, foundations, like how's everything in the sub getting held up, supported, right? And then on the electrical engineering side, that's the biggest piece of this typically. That's broken out into what we at EVS we call this physical engineering. That's sort of the layout of the substation. Where's all the equipment going to go? How far is it going to be spaced? What are we meeting all the required clearances? What type of conductor are we going to use to connect all the equipment? How are we protecting the substation from lightning strikes? And so the physical design, in my opinion, is kind of it's like the link between all the other disciplines. You got to talk to civil and make sure that your site is flat enough, appropriately graded, your basin's not in a place where it's going to cause problems. You certainly are very intertwined with structural, because if I want to stick this piece of equipment on the structure, you got to talk to them, make sure it's in the right place, make sure the mounting pattern is correct. And then the next electrical engineering facet, what we call P&C, protection and controls, physical is very intertwined with them as well. And so
you're leaving out your geotech friends.
You're right. Yeah, I left that.
They're also there.
Yeah, geotech and survey actually.
Yeah.
Those are kind of early stage things typically, but you got to do geotechnical engineering, and that's closely coordinated with structural to do the foundation.
Is there also probably like thermal resistivity kind of things too, and like electrical parameters from the geotech? So yeah, it's all there.
Yep. Yeah, that ties into the grounding design. That's for us a specialty.
So there's also studies on substation.
Mm-hmm.
You got it?
We wait for the infamous GA, so that we can kind of the in general GA general arrangement. Yeah, so we can kind of import it into our CAD and then make sure those lines are just not terminating in space.
Yeah.
Right.
So y'all might not know, but Colin and I actually worked at our previous company together. So we've probably been working together for like 10 years.
Yeah.
And I cut my teeth in substation design, and we would sit and we'd get in a conference room together. We work on the same project. I was electrical, he was civil, structural, and we would just like hash out the design, and you get really close with your civil structural folks, spend a lot of time in design. So
Mm-hmm.
Are the time frames for substation very similar to like PV?
no.
Because like I know you said 38% IFC. I think typical for PV is what, 6 months, 8 months maybe, to get it from 30 or bid support level all the way to maybe IFC.
Oh, yeah. Yeah, for PV, yeah, but
Yeah.
substation, how is that? That's not the same?
I mean, just like PV, it depends a little bit on the project size. You know, if for a really big project, say you're trying to transmit 500 megawatts, right? You're probably going to have 2 or 3 transformers there, and that greatly increases the complexity and the amount of time that goes into the design. But if it's a smaller 100 megawatt project, 1 transformer, it's a little bit simpler. It goes a little bit faster. The other piece of it is that the different disciplines I mentioned, I guess I didn't talk about PNC. Maybe I should cover that quick.
Let's talk about PNC.
So protection and control engineering is, it's kind of the brains behind the substation. Every substation has what we call a control house or a control enclosure. And inside that, there's a bunch of equipment, but the most important piece is there's all these panels, right? Those panels hold a bunch of different devices, but the one that's most relevant here is relays. What a relay is it's essentially, it's taking information that it's receiving from equipment inside the sub, voltage, current, sensing that stuff. And if it senses an irregularity, a fault, an overcurrent, some type of irregularity like that, the relay senses that, and then it's going to tell a circuit breaker to trip if it needs to, right? And so that relay is talking to the circuit breakers, and that's how the substation protects other parts of the grid and protects specific pieces of the substation as well. You know, so if you say, for example, you're connected on the low voltage side to the PV plant, and you sense those relays sense a fault coming in from one of those PV feeders, it'll trip that breaker, and now that fault can't impact anything else inside the sub. You know, and so the whole point of the protection and control system is to protect and control those breakers and some of the other equipment to make sure the substation functions as it's supposed to, and also protects other parts of the grid. You know, if there's a problem on the grid, you want to protect stuff on your end and vice versa. So
is SCADA and PNC kind of correlated, or do they work together?
Yeah, they are probably the most. SCADA is probably most correlated with PNC, and SCADA stands for Supervisory Control and Data Acquisition.
That clap.
And
Clap track.
so the purpose, at least in the context of substations, SCADA applies to lots of different industries in different ways, but in the context of the substation, the purpose of SCADA is really to communicate information, right? So it's that SCADA, we have what's called an RTU, or remote terminal unit. That's kind of the brains behind the SCADA system. That's talking to all the relays, right? So if a relay trips, does something, senses something, all that's being relayed to the RTU. And then the RTU is also talking to the PV plant, the solar plant. If there's battery plant, it's talking to that. It's talking to the utility we're connected to. It's talking to the independent service operator, the ISO, any other relevant parties that RTU is talking to. So it's kind of like a data aggregator and throughput. Is just passing information along.
Okay.
Say this on recording, but
we're recording now.
For a structural engineer, you're impressive with your knowledge of electrical. I know you don't feel that way, but I'm just sitting here listening to them like, you know your shit. You give yourself some more credit.
When the transformer is stepping up the input voltage to the output voltage, what is happening in there?
Yeah.
Like
What's the transformer doing?
What is it doing?
So in its name is transforming, right?
Yeah.
But what you have is you have a primary and secondary side. So you have like your low side, the 34.5 kV side coming into the transformer, then you have your 345 going out of the transformer.
It does 10 times as many.
Right.
Or in the transformer, you have
a different voltage, like whatever the ratio is.
So you have coils inside your transformer, right? And so on, and because like when you transform that voltage, there's nothing physically touching between the one side to the other side. Yeah. And so the one side's gonna have more turn ratios to step up your voltage, or to step down and you go the other way, less turn ratios.
Okay, what is it about the turning?
It's magnetic.
Amplifies it. Okay, yeah. So it's an induction.
It's an induction.
Thing. Okay. Yeah.
And so it's very efficient. Transformers are very efficient to transform.
So there's like no loss, or very, very little.
There's very, very little.
Yeah.
But what I was saying was, there was a point in time in history where, today's day, I think DC current they're able to transmit over longer distances than maybe we could 100 years ago.
Yep.
And I don't know too much about transmitting the DC over transmission lines.
Right.
There's some efficiency breakthroughs that they've had, but the argument, was between Nikola Tesla and Edison and DC or AC. And Edison's mind, he was going to have these power stations every few miles to transmit the DC, where Nikola Tesla figured out that if you just use AC and you jack up the voltage and the current goes down, you can transmit it over long distances with very small losses.
Right. And that's the other thing too, is like when you are taking the input voltage, the current is a lot higher, right?
No, so the higher your voltage, the lower your current.
Yes. So when you do that though, you put in the input voltage, the current is X, and then you at the output, then it's like a lot of voltage and less current.
Yep.
Okay.
Yeah.
And you want that because low current means low losses.
A P equals IR squared. There's you can manipulate the equations.
From the procurement standpoint, going back to these transformers, what are the lead times you're looking at right now?
I mean, transformers have always historically been kind of the long lead time thing, multiple years. And so a lot of times when you start a project, the owner of the project they'll initiate the procurement process to go buy and get that transformer, years before they even start design on the project, right? And so usually when we do detailed design on a project, the owner gives us the transformer. They tell us, this is what we're using, make your design work with this. That's normal. What we've seen recently, I mean, really equipment across the board, the lead times have just gone up exponentially just due to demand. There are so many substations trying to be built these days that the demand for equipment is insane, but especially high voltage circuit breakers, the lead times have actually gotten up even higher than transformers in some cases. We have a project in Texas going on right now where the lead time is like over 4 years. It's crazy.
4 years?
I'm trying to remember as having a conversation a few months ago about how these hedge funds are actually purchasing these transformers in these circuit breakers.
Oh, yes. Yep.
Were we part of that? Yeah. And they're like using that as an investment. So they'll purchase them and then years later, they'll appreciate. Yeah. It's kind of wild.
It's almost a gold now.
Yeah.
So we worked on this project in New Jersey that was I think it was the oldest substation in the country.
Yeah, I remember there were some drawings that we worked on that were dated from like the 1920s or something.
Yeah, it was pretty wild.
Yeah.
But they had this big expansion to a 345 kV yard, and they had these two transfers, one for 138 and one for 230, switching to 345. And I think the lead times for those transfers was like 5 years. So when this utility purchased those two, they purchased two extras at that same time because they knew how long it was. And then they ended up like storing these backup transformers. And we did a design where we installed stuff like, for them, it was if one of those main transformers goes down, the loss in production is so high per day, then they wanted this, they spend $5 million on this other transformer that can switch and go. But the funny part of the story was we were doing the design and they lost one of the transformers. What? Dude, we're talking about was it a 1 million pound transformer? And they're like, we don't know where we put it. It was just gone. And they finally found it, but it was quite comical. Like, how do you lose a $5 million transformer, But,
It was just in the other building.
Yeah.
I thought it was in this one.
well, they stored them outside. Yeah. We don't really do procurement, do we? As of yet?
We do what I would call procurement support.
Okay.
So our clients will often come to us and ask for us to support them. So we'll write specs. We'll figure out what ratings that equipment needs, all kinds of other design parameters that the equipment vendor then would take and use that to educate how they build it. And so, sometimes if it's long enough lead time where they have to buy it before we get involved, then they'll just give it to us and say, make your design work with this. But for some of the what I'll call smaller equipment that isn't quite as long of a lead time, we'll spec that equipment, so that it kind of works with our design.
Well, the procurement process though is like it's like a full-time project on its own.
Yeah.
And it's I know we've done it before in the past, and it's very involved. And for a substation, I mean, it's down to the nuts and bolts that you're getting quotes on, and then you have to send it out to so many people, and then you have to like double check to make sure that quote has all the material that needs, and if not, then it's on you and you get to the site and they don't have what they need, and they're like, oh man. It's a pretty big lift. for sure.
Is that why the gray hair was?
Too much procurement.
Too much procurement. Wow.
Now, coming back to what we kind of do, could you talk a little bit about, I know you guys work with the studies team quite a bit to help with capacitor bank sizing and that kind of thing. Maybe you could talk a little bit about that. I know the design team doesn't get very involved with the substation team, right?
Yeah,
Tell us about your relationship with the studies team, Colin.
Well, our studies team is in the unique position where they get to kind of be the bridge between the PV design and the substation design often. And so we'll use, I'm speaking for us here. So you cut me off when I go off track, but we use modeling software to model that system all the way from the PV generation or battery generation, whatever it is, all the way up to the high voltage transmission line. And so the reason for that is because it's all, even though they're maybe separate scopes, separate projects, the solar and the substation, they're all connected electrically, right? And so our studies team will model those things and analyze reactive power, short circuit, ampacity in the cables, things like that. And so they very much need to work with both the PV team or the BESS team and the substation team and make sure that that's all kind of holistically being considered accurately.
So for projects that we don't have substation in-house, we typically, our studies are ending on that low side of the substation where we are determining reactor size, if we need a reactor or capacitor bank size, stuff like that. But when we have projects where we have the substation out, we're doing all the studies inside the substation as well. Okay. So we're considering that. So even when we don't have the substation scope, we're still having to model the substation, but we're not the ones in charge of saying you need to, this spacing up to your risers for, your MB cables or whatever other studies. Arc flash would be a good one. Like we're not responsible for doing arc flash study for the substation, but when we have it all, we just kind of just do it all.
Okay. Interesting.
So in the example you brought up of cap banks and reactive power, right? Our studies team, because really the reactive, like the cap bank size inside a substation is determined mainly by the PV design or the battery design and the inverters and whatever that arrangement looks like. And so our studies team is the crucial link between the two there because they're considering what's happening on the plant side. But then if we need to add a cap bank, that's something that's in the substation. So we got to work together to figure out, does this need to be 10 MVARs, 5, more than that,
steps,
whatever it is. Yeah, multiple steps. So
and it's a lot easier to, not that it's always difficult, but it is easier when substations in-house to have that conversation. So if another, engineering firm is subbed out to do the substation design, sometimes there's some back and forth because they'll do their own reactive study in which they're not considering the PV at all. They're kind of, it's a black box for them, right? And they're making some sort of assumption. And then they'll come back and say, oh no, we actually have a smaller cap bank size requirement. Right. And those type of projects have been very difficult because we'll say it needs to be this and they'll say it needs to be that. And then they procure that. And then they're like, and we've been on projects where like, make this work, and sometimes it just doesn't, and those cap banks aren't cheap and there's long lead time on them. And, so it's much more beneficial if we could get the entire design in one spot.
How big are these cap banks? Do you know, like, is it
physical size?
Physical size.
It depends on how many capacitors are on it, right? And how many steps it is, but they can, I think we have one on a project in Texas right now that's, they're probably 15, 20 feet tall and 30 feet long, something like that. They can be pretty big and they come on their own like little vendor provided structure, right? So it'll come assembled on site and they will provide foundations that they set on.
Okay. It's like a battery container pretty much.
Yeah, in some ways, yeah.
Mm-hmm. Yeah. Because they're in the air usually.
Well, Colin, what else would you like to say about the future of substation before we turn you loose?
There's a lot of work out there, and I'm looking forward to the substation department continuing to grow, continuing to do more to help the onset of renewables in the United States.
If you had to give one piece of advice, this is the question we ask all of our guests on the Sounds of Solar podcast. If you had to give one piece of advice to someone entering, whether it's a new grad or an experienced professional entering the renewable energy industry, what would that be?
Stockpile.
Besides get a taser, sorry. What do you say?
A stockpile transformer?
Yeah, that.
Transformer.
Mostly that, actually.
I think two things, I guess. The first, I feel like I've been really fortunate in my career that I've always been surrounded by what I felt were like really competent and experienced engineers that kind of served as mentors, right?
Oh,
It's
thank you.
important, mainly Russ. But I think, in today's day and age, it's all about how quickly can you get this done? How much can we come in under budget and those types of things. And so you try to build things out in a way that you can automate them and get them done as effectively as possible. And sometimes that can turn into, you're just plugging some numbers in and then you look at the output and you don't really know what's happening in the middle. And in order to really be a effective engineer, I think you need to really cultivate that ability to understand what's going on there. So then when something weird happens, something goes wrong, you can analyze the situation and know what needs to be done, right? That's part of being an engineer, I think. And so seek opportunity, seek mentors, seek opportunities to really understand what's happening and don't just plug stuff in and then use the output. The other thing I would say is say yes to things. When I first started having discussions about becoming the substation manager here, my first question was, well, I'm a civil engineer. I don't know that much about electrical engineering. And, there's no better way to learn stuff you don't know when, other than someone asking you a question you don't know the answer to, you got to go find the answer, Yeah. And so that it goes back to the first thing, like have knowledgeable, experienced people around you can ask for help and learn things from, but then like put yourself in situations where you got to figure it out. That's the best way to learn something, in my opinion.
Yeah, and at EVS, I think we have such a great supportive cast of characters that are just fun to work with and very knowledgeable, and it's kind of the best place to do exactly that.
Yep, agree.
All right, Colin, thank you so much for joining us on the Sounds of Solar podcast. We hope to have you back very soon. But for all of us here, Prahalad Shivshankran, Russell Hamilton, I'm not going to say anything about your nickname or mine or anything. So
We'll leave those nicknames.
we'll come up with new ones.
I'll find it.
We use ChatGPT to come up with some new ones, and we'll introduce those on the next show. All right, so from everyone here, thank you so much for listening. Share with your industry folks, now your substation friends.
Yep.
They should tune in. We'll see you next time on the Sounds of Solar podcast.